Okay, so we hear it all the time, right? AI is learning. But what does that actually mean? I mean, it's just code. There's no brain, no real memories like we have. So, how in the world does a bunch of circuits go from zero to, well, so incredibly smart? Let's dive in and figure it out. Just picture it for a second. How can a machine start with what is basically just random noise? A jumble of pixels on a screen or static from a microphone, and then somehow turn all that chaos into something that can recognize your face in a photo or understand what you're saying. It seems impossible, almost like magic. But the secret? Well, it's actually inspired by something we're all very familiar with. A machine that guesses. Yep, the whole idea is basically borrowed from our own brains. We're going to break down how a machine can learn to guess, mess up, and then get a little bit smarter each time, all without actually thinking the way we do. The tech that makes this all happen is called a neural network, and I really want you to focus on that phrase on the screen in a very simplified way. This is not, I repeat, not a real brain in a box. It's more like a mathematical sketch inspired by a brain, just a big web of digital points and connections designed to do one thing: crunch numbers. So here's the absolute key difference. In your brain, you've got neurons firing off all these biological signals, right? It's messy, organic stuff. In a network, you've got these nodes that are just, well, they're just calculators. They're processing mathematical values. It's the difference between a living thing and a really, really powerful spreadsheet. Biology versus pure math. Okay, so let's get into it. Part 2, the digital brain idea. If it's not a real brain, then what does this thing actually look like? How is it structured? Well, it's actually way more straightforward than you might think. It basically works in 3 simple steps. First, you have the input layer. Think of this as the eyes of the system. It sees the object for the first time. Then you've got the hidden layers. This is where the real brain work, quote unquote, happens. It's breaking down all the clues, the shapes, the colors, you name it. And finally, you get to the output layer, which is where it makes its final guess. So it's see, process, guess. That's it. But here's a really cool part. Every single connection between those nodes has something called a weight. You can think of it like a little importance dial. If a certain clue, say the shape, is super important for figuring out what the object is, the network can crank up the weight on that connection. If the color doesn't matter, it can turn that one way down. This ability to adjust these weights is the absolute secret to how it learns.
All right, part 3, the kitchen learning test. Enough with the theory, right? Let's make this real. We're going to take our brand new AI, plop it in a virtual kitchen, and try to teach it how to recognize something simple.
Okay, first up, we show it a picture of a fork. Now, at this point, the AI knows absolutely nothing. All those weight dials we talked about, they're just set to random. So it looks at the pixels, runs the numbers, and spits out its very first, totally clueless guess. And it says, "Is this a spoon?" Nope, wrong. And this moment, the mistake, is honestly the most important part of the whole process. Because now we can give it feedback. We tell the system, hey, that specific pattern of lines and dots you just saw, that's not a spoon, that's a fork. And that is what we call training. It's this feedback loop. Every single time it gets something wrong, it goes back and just nudges all those little weight dials. It's basically asking itself, okay, which of these dials should I have turned up or down to get a little bit closer to the right answer, fork? And you have to understand, this doesn't happen just once. It doesn't see one fork and go, got it. This loop of guess, mistake, adjust happens again and again and again. We're talking millions, sometimes billions of times, with thousands of different pictures of forks from every possible angle. So let's fast forward. After all that, our AI is now a world-class fork spotter. But here's the million-dollar question. What did it actually learn? This is where we need to be really clear and separate the cool reality from the sci-fi hype. This right here says it all. When you or I see a fork, we know what it's for. We think about eating, about pasta, about its function. The AI, it has zero concept of any of that. For the AI, a fork is just a statistical pattern. It's learned that this specific arrangement of pixels has a very high probability of being associated with the label fork that we humans gave it. This is so important to grasp. The AI doesn't understand forkness. It doesn't know about food or kitchens or that you shouldn't stick it in an outlet. All it has done is build a really,
really good mathematical model of the shape of a fork. It's a master of patterns, but it has no idea about purpose.
So you might be thinking, okay, big deal. It's just a glorified pattern matcher. And you'd be right. But here's the thing. It turns out that being the best pattern matcher on the planet is an insanely powerful skill. Because that same simple idea, guess, be wrong, adjust, is the engine behind almost all the AI you interact with. Recognizing a face in your photos? That's just a pattern of pixels. Understanding your voice commands? That's just a pattern of sound waves. Recommending your next show to binge? That's a pattern in what you watch. Even self-driving cars spotting a stop sign. It's all just pattern recognition scaled up to an incredible degree. But, and this is a huge but, this whole method leads to a really critical limitation. Since it only learns patterns and has zero context, you get what you could call the common sense gap. And we absolutely have to remember this. A neural network can be trained to identify a cat with near-perfect accuracy. But it doesn't have the common sense to know you shouldn't put a cat in the dishwasher. It's not aware. It has no true understanding. At the end of the day, these things are just unbelievably powerful pattern recognizers. Full stop. So this really is the key takeaway. When you hear that AI is learning, what we really mean is that it is just adjusting a massive set of numbers over and over until it gets really, really good at predicting a pattern. It's not thinking, it's optimizing. It's math, not magic. And that leaves us with a really big question, doesn't it? If we've built this brilliant, ultimate pattern matching machine that can see things in data that no human ever could, the real question for us becomes, what patterns should we ask it to find next?